My name is Michael Collins. I'm an emeritus chemistry professor at Viterbo University in La Crosse, Wisconsin. And I'm going to show you today how you can use the laboratory interface from Microlab in conjunction with a computer to record an experiment that measures time and temperature so that you can determine the freezing point of, in this case, glacial acetic acid. So at this point, we have the box communicating with the Microlab software. So I'm going to open the Microlab software, and you'll notice a blue bar that indicates communication. If you don't get this bar, it means you probably either plugged it into the wrong USB port or else forgot to turn on the Microlab interface. So if that happens, just close the program, reconnect things as needed, and then go back and start the program again. So I'm going to open a Microlab experiment. Okay, so we're going to start by adding the sensors. So I'm going back to this upper left-hand corner box. I'm going to click on the button that says Add Sensor, and we get this dialog box that comes up that shows kind of a rendering of the Microlab FS522 interface, and we have a drop-down menu with a list of all the potential sensors. The first sensor I'm going to add is temperature, and you can see we have three different temperature sensors. We have an IC probe, a thermistor, and a thermocouple. The thermistor is the one we're choosing. We're going to choose an input, and so we have to figure out where we're going to plug it in. So I'm going to plug it in to port A. On the picture, that would be this one right here, port A. So I'm going to click on that, and that now tells the program where I've plugged in my temperature probe. I'm going to click on Next, and at this point we get a dialog box that tells us that we're going to calibrate the probe. We're going to get units of Celsius, scientific unit of temperature, and the unit that we're going to display would be a capital C standing for Celsius. To perform the calibration, I'm actually going to read this from a calibration file that's already built into the software. So here we have a dialog box with the calibrations. The temperature probe that we are using is the model 103 thermistor. We're going to click on that. CFT is the calibration file. We're going to open that, and you can see now what the calibrations are over a range of roughly minus 60 degrees to plus 100 degrees. And now we will finish that. When we finish it, you can see up in the left-hand corner, we now have the thermistor probe in the variables. We're going to add one more sensor, and that is the time. So the drop-down menu comes back. We're going to choose time. And the Microlab FS522 interface has three built-in timers, so you could time up to three different independent events. We're going to choose the first one because it's number one. The label will be time 1, and the units on that we can choose as seconds, and we're going to set it up so that it starts at 0 seconds when we begin the program. And we're going to finish, and now we have our two sensors, temperature, thermistor A, and time 1. So I'm going to first put time and temperature into the spreadsheet by clicking and dragging the sensors over to the spreadsheet. I'm also going to prepare a graph of time on the x-axis versus temperature on the y-axis by clicking and dragging over to the graph window. And if we want to read the time and temperature in big numbers, we can take them over to the digital display. And the time is 0 because the timer's not running. Okay, we'll go back now to the experiment steps. And the experiment that we're going to do will consist of just a simple loop of repeating every 0.5 seconds, every half second, reading the sensors, reading the time, reading the temperature, and then repeating this step until the user, clicks on the box that says stop. It's that simple. So now we've built our experiment. Let's do some chemistry. The experiment that we're going to do today involves the freezing point of glacial acetic acid. Glacial acetic acid has a freezing point around 16 degrees Celsius. Since it's 24 degrees in here today, at room temperature it's a liquid. If we put this into an ice bath, it will freeze. So our simple experiment that we're going to do today involves freezing glacial acetic acid and using the microlab interface to determine the temperature of the freezing point. So I'm going to start the experiment by inserting the probe into the glacial acetic acid so that we can measure the temperature of the acid. Then I'm going to start the experiment by clicking on the start button. All right, you can see now we're putting time and temperature into the spreadsheet. We're putting time and temperature into the graph, and we're seeing the time and temperature change down in the digital display window. Safety first. I'm going to put on my safety glasses. This is a chemistry experiment. I've got an ice bath. I'm going to take the test tube with the glacial acetic acid and place it into the ice bath and start cooling off the glacial acetic acid. As it crystallizes, the temperature comes back up because crystallization is an exothermic process, and we eventually get to the freezing point of glacial acetic acid. You can see that we have a very nice cooling curve developing here that shows us the freezing of glacial acetic acid. And if we look in the test tube, we can start to see crystals forming in amongst the liquid. And I'm going to stop the experiment. When I stop the experiment, it auto scales, and you can see the cooling curve that we have. We can zoom in, select the domain, we get this magnifying glass, and we can click and drag around the area we want to look at and blow that up. We can zoom in again and actually get an even more precise estimate of that. So the temperature seems to be somewhere around 13.9 degrees. And there we have it, the freezing point of glacial acetic acid. Now if we want to save this, let's zoom out to get the screenshot. Now here I'm actually going to show you how to save the experiment. So we have the experiment, it's not saved, it's just there. If we want to save it, we can go up just in a normal Windows environment and click on the Save button. And this brings up a dialog box. We can change the place where we save it to, put it in any document file. If you have a flash drive, you could save it to a flash drive. I'm going to save it to the desktop, I hope. And we're going to call this experiment 1. Let's try that again, exp1. And I'm going to save that. I would recommend somehow putting your initials or your name on the thing when you save it. The other thing we can do if we want to get this into an Excel file is rather than save it, we can go up to the file box and we can export it. So we can export the data as a comma-separated file. And notice now it's a comma-separated file, and let's call this experiment 1 as well. There we go, and we'll save that. When you do that, it automatically opens Excel, and it gives you the time and the temperature in the same columns that you put them in when you were designing the experiment. And we can actually, in a normal Excel way, we can click and drag around the values that we have in the 100 seconds to choose our data that we're going to put into a graph, and we can insert a graph. So let's build a scatter graph, and there you have it. And again, once you're in Excel, you can do whatever you want with building the graph, changing the scales, formatting it, and so on. The other thing that you can do is you can import, let's go back to the microlab. We can highlight a window such as, let's say, the graphics window. I'm going to highlight that, and I can copy it. And I can open up, in this case, say a PowerPoint file, and I can actually paste that in and we can get the window into PowerPoint for a presentation. You could put this into Word or any other Office program that will allow you to do the normal Windows copy and paste. So that's it. You could use the same experiment to do solution calorimetry or any other experiment really where you want to measure the temperature as a function of time.